Still in Unit 2, today we just talked about circles. So here's the real equation of a circle in what we call center form, center radius form, because you can tell the center and the radius of the circle from this form. The center of the circle is at HK. It's very much like our graph translation theorem, where they have the opposite in front of there also. So if you had an equation like this, you can tell the center and the radius from it really easily. The center is the opposite of this and the opposite of this. The center of the circle is at 2, -3. Right? It's the opposite, because in the formula there are minuses. This is the radius squared right here. So our radius is the square root of this guy, which is 4. Equal center radius 4. You'll see a plain Jane guy, that's where the center is at 0, 0, because they don't want to say x minus 0, 1 squared plus y minus 0, 1 squared equals r squared. There's no need to put the minus zeros in there. So this is as plain Jane as it gets. The center of your circle is at 0, 0. So if you see x is getting squared and y is getting squared in the same equation, that'll turn out to be a circle. Okay? It is not a function, obviously, because it doesn't have the vertical line, it has function graphics. So use the graph translation theorem to find the center and the exact radius of each circle. This guy, since there's nothing happening to x or y in the parentheses, his center is at 0, 0. And his radius, remember you just got to square root that time right there. So the radius is 7. People, you do know that there's also -7. It's the square root of 49, but obviously the radius is negative place, right? So that's just 7. Alright? Here, here's my center. It's opposite both times. That's a -3, correct? And this will be a positive 4. Good deal? And our radius is the square root of whoever he is, which would be 4 in this case. Rock and roll? Pretty simple concept. Center radius 4. Again, center of this guy would be 5, 3. Down with that. Radius of this guy, since 24 is not a perfect square, it is the square root of 24, but we need to simplify the radical if possible. Putting your perfect squares, thinking about perfect squares, you know, 1, 4, 9, 15, 25. 25 is too big. 16 does not go into 24 evenly. 9 does not go into 24 evenly. Doesn't 4 go into 24 evenly? So you split them up into 2 radicals. 4 goes on the left. That's your perfect square, right? How many times does 4 go in there? 6. And then over here, you simplify that part because we know what the square root of 4 is. It is 2. So 2 square root of 6 is 3. Awesome. Remember simplifying radicals? Are we okay with that, or do you want me to explain that further? Cool. This guy over here, center. What do you think? -2.2, comma, 0. Square root of 28. You want to simplify them though. Thinking backwards, 25 doesn't go in, 16 doesn't go in, 9 doesn't go in, 4 goes in, right? How many times? 7. So 2 square root of 7. And I'm to the point where if you can simplify it right away, I don't need you to show me work. Okay? If you can do that mentally, I don't care. If your calculator does it for you already, I guess benefit you, right? That's the point of this class. Let your calculator do everything for you. That's great. Alright. Find the center radius form of each circle satisfying the condition. So they tell me the center, they tell me the radius, they want us to write the equation. So that would be the quantity of x. What should I do? +6 or -6? -6, don't forget. Squared, that's the big thing I would forget. And then the symbol between is a what? A plus or a minus? Plus y minus 9, quantity squared. And don't forget, if the radius is 4, you need to square them and get 16. Awesome? Yeah? Center 0, 0, so you're doing just plain Jane x squared y squared equals. Squaring this radius is where we'll have our trouble. Okay, we have to square 3/3 steps. So I'm just going to do some work off to the side where I got room to write. This is what I'm trying to do. Don't forget what squaring really means, is you're trying to take that times itself. So you're really taking 3 squared to 7 times 3 squared to 7. Put another 3 in there, correct? You have to take numbers times numbers. What's 3 times 3? 9. Square root of 7 times square root of 7 is the square root of 49, which is really how much? 7. So you have 9 times 7, which is really 63. The easy way to do it, in my mind, is do this. You got to square the 3 and get 9. You got to square this and get 7. And then you multiply that together because isn't that what's going on? So you got to take 9 times 7 and it gives you 63. Okay? So just for a little bit of practice, what's 2 squared is 5, quantity squared is going to be. This would be 4 times 5, which is really 20. And then 8 squared is 2, quantity squared, 64 times 2, 128. Cool with that? Alright. So now is where they ask us to do a little bit more stuff. There's 2 ways to do these problems here on like number 7. They tell you the center, and they tell you a point that it goes through also. Correct? You could use the distance formula to find the distance between those 2 points, because just check it out. I have a graph here to show you some distance. The percentage of 3, -5, and it passes, that's the center, right? And it passes through 1 core. Right? Isn't the distance between those 2 points the radius? Right? This is the point on the circle, and it would be all the way around, etc. That's the distance between them. It's the same thing as doing this. If this is the generic formula, don't we have h and k right here, and we have an x and a y value right there? We can substitute all 4 of those things in, and that will tell us what our squared is. So let's do that. What will I put in for x? 1 minus 3. Y'all cool with that? Quantity's got to get squared. Plus y, which is 4, correct? Minus 1 quantity squared is equals r squared. There were 5 variables in that formula. H, K. Plus 5. Way ahead of myself. There were 5 variables in that formula, h, k, x, y, and r. We knew h, k, x, and y. We just don't know r. Rock and roll? So, to simplify, you got to do what's in here first. 1 minus 3 is -2. Then it's got to get squared. What would you get? 4. 4 plus 5 is 9. Then you got to square it and get how much? 81. And that equals r squared. Add them together. 85 equals r squared. And honestly, if you wanted to solve for r, you'd get the square root of 85. But you don't need to solve for r, because don't you really need to know what r squared is in the first place to put it into the formula? So our actual formula would be x minus 3 quantity squared plus y plus 5 quantity squared, right? That's our center. Would you agree with that? That equals the radius squared. And what's the radius squared? 85. And quite honestly, that is the distance formula. If you do the distance formula, you do the same thing, except you square root this whole thing, and you solve for r, right? I mean, it's the same thing that we just did. Exact same work. So all I did was substitute into my generic blue formula, figure out what r squared was, then go back and write that down. Cool? This guy right here, again, I have a graph to show you what's going on. When you don't have a graph, you can always sketch a little graph and kind of plot these points generically and see where they're at. They say the center is at 4, 6. There's my center. And the circle itself is going to be tangent to the x-axis. It's been a while since you've heard the word tangent. Talked about it a little bit in geometry, probably a little bit in FFT, but if I have a circle and I have a line of tangency, it means it touches it in one spot. A line of tangency just touches any particular graph in one spot. See what I was drawing before on accident? It would not be a line of tangency because it only touches in 2 spots, right? So it touches it in one spot. So if this is the center of my circle, which they say it is, and it's got to be tangent to the x-axis, would you believe that my circle would have to touch the x-axis right there? That's just the only place it would touch it. So this is the radius of that circle. Correct? Right, that is the radius of the circle. How far is that? Isn't that a vertical segment right there? And this is the point 4, 6, right? So is that 48 long or is that 16 long? How far is that? Isn't that 16 long? We figured out that the radius equals 6. Because the center is here, and it's got to touch the x-axis. Shortcut. If it's got to touch the x-axis, then the radius is the absolute value of y. Right? It's how far you are up on the y value. You know, so the radius has got to be 6. Okay with that? So I know the radius is 6. I know this is the center. I can write the equation that real simple. X minus 4 1 squared plus y minus 6 1 squared. Again, that's just the center, right? And my radius is 6, so what do I equal right here? 36. One more time, tangent to the x-axis means look at your y value, right? And think of it as positive. Because if that was like a negative 6, we'll see on the next example, the radius can't be negative 6, right? It would still be 6 units from the center. So let's try that again. If the center is here, and it's tangent to the y-axis, right? That means which value do I care about if it's tangent to the y-axis? The x. This is negative 5, correct? But you can't have a radius of negative 5. What will my radius actually be? And I will show you that again. I have a graph. Negative 5, negative 7. There's the center. There's my center. And it's got to touch the y-axis. So wouldn't that be where it would touch the y-axis at? What's the distance from C to that point? It is 5 units. Right? It can't be negative 5 units. So my radius is 5. X plus 5 quantity squared plus y plus 7 quantity squared equals how much? 25. Sweet. Moving pretty fast. Are we doing all right so far? This is the one we'll probably make some mistakes on also. They tell me that 2, 6, and negative 4, negative 2 are the endpoints of the diameter. If I draw a diameter of a circle, I don't care about the diameter of the circle. I care about this one, the center of the circle. Don't we need the center to figure things out? How does the center of this circle relate to this segment right here of the diameter? Smack dab in the middle. If this radius is 5, would this radius be 5 also? Isn't this the midpoint of that segment? Correct? So we need to find the midpoint. Let's make ourselves some notes so that way when you have your homework problem like this, you know what to do. Number 1, find midpoint. How do you find the midpoint? So many formulas that you did back in geometry. Holy cow, formulas out the wazoo. The midpoint is so simple. It's finding the average, right? You add stuff together and divide by 2. You need 2 points though. You need an x value and a y value. So to find the midpoint of an ordered pair, let's add our x values together. 2 plus negative 4 is basically writing 2 minus 4. And then you divide it by 2. To do that with your y values also, you add your y values together. 6 plus negative 2, same thing as saying 6 minus 2, and you divide it by 2. Notice I wrote a big, like, fat ordered pair. I've got x information in green, y information in red, and all I'm doing is adding my x's together, dividing by 2, adding my y's together, divided by 2. What would I get shooting out of the green situation? Got to do the numerator first. Negative 2 minus 4 is negative 2, divided by 2, what do you get? You get 1. How about a red number? 6 minus 2 is, divided by 2 is, all you do, add your x's together, divide by 2, that's the x value of your midpoint. Add your y's together, divide by 2, that's the y value of your midpoint. So, this is the midpoint of that diameter, which is called what of the circle? We found the midpoint of the diameter. What is this really called? The center. So label that when we make it. We know the center is there. We're cool with that so far. Now what else do I need to know to write the equation of this circle? I need to know the radius. Well, this is a point on the circle, and so is this. This is a point on the circle. I don't need both of them. I just need one of them. Can we do the same thing that we did back here on number 7? If I know the center and a point on the circle, can't I use this generic formula right here and sub in? So you must make sure that you're using the right 2 points. You have to use the center, and then which point did you use? It doesn't matter. Out of those 2, either one will work. So again, I like to say here's H, and I'm just going to use this first graph. Here's X and Y. I could have used this point over here also. Isn't this a different point on the circle? Doesn't matter. But you must use the center, and you must use any other point on that circle. So if the generic formula is this, all you have to do is substitute in. just like we did before. Do you know h, k, x, and y, but you don't know r? So let's do that. What's that? 2 minus h, so wouldn't that be plus 1? 1 is got to get squared. Y, I'm using 6, minus k, which is 2, equals r squared. Cool with what I did. Okay. 3 squared is 9. Maybe 2 right now. 4 squared is 16. That equals r squared. So r squared equals 25. You can mentally figure out that the radius is 5. But you really don't need the radius. You need the radius squared. So write your actual formula. That there was it. So step 1, we found the midpoint. Step 2, use the center. And another point to write 1. First you have to find the midpoint, keep the center of your circle. Then you need to find the radius. So I use the center and another point to write our formula and solve for our radius. Got it? Final thing, baby. They give me the equation of a circle. How do I know it's the equation of a circle? It's got x squared and y squared in it. But it also has x to the first and y to the first in it. This is the equation of a circle. It is not in center radius form. How you put it in center radius form is you complete the square. This is one of the main reasons why completing the square was invented, was to say, I would like to put this in center radius form. Easy way to do it. All your x stuff has to be together in order. So let's write x squared plus 6x, and let's put a plus blank with it. Completing the square is all about putting the plus blank. Then y stuff comes next. I'm changing colors for you. Goes in order, y squared minus 14y plus blank. All constants go on the other side. So you see this minus 23 was a constant. Add him over. You have 23 over there. And you need to add your 2 blanks from the other guy. You had a red blank and you had a blue blank, because if you add something to one side of the equal side, you got to add it to the other. Keep that balance. How do you fill in the blanks? We kind of had trouble with that. I need to hand those homework quizzes back to you. We kind of had trouble with that, filling in the blanks on that homework quiz from a couple times ago. Take half your b value and square it. What's half my b value? 3 squared is, and add it over here also. Because if I add 9 to the left side of the equal sign, I got to add 9 over here to keep it balanced. The blue blank, negative 7 squared is 49. Goes in both blanks. Cool? Now, we factor both parts. The red part is a perfect square trinomial. We didn't do that very well in our homework quiz either. The square root of this guy is x. Then you need to bring down the square root of this guy. Who is the square root of 9? 3. And which one do you want? You want whatever sign this is right here. So you want a positive 3. And that would be quantity squared. This red thing is a perfect square trinomial. That's why we call it complete the square. 9 completed the perfect square trinomial. It factors into x plus 3 quantity squared. Then the plus comes down. The blue thing is a perfect square trinomial also. Let's see if we can factor him correctly. It would be a quantity of, you know, the square root of y squared is y. You need the square root of this guy right here, which is 7. But which one do you want, a positive or a negative? Negative, because it's a quantity squared. And then you add all this stuff together. 23 plus 9 plus 49, 81. Awesome. That is the equation of this circle in center radius form. But they ask us to identify the center and the radius. So you will need to tell me center. Who is the center? Negative 3 7. Right? And then the radius is 9. Awesome? So let's do one more of this. We need all the x's together, all the y's together, with blanks. Constants go over to the other side. I'm just going to put this into 3. Alright, x's together, in order, y's together, in order, couple plus blanks, and don't forget to put the plus blanks on the other side also. Fill in them blanks, half the b value squared. Check your blanks with my blanks once you fill them in. Alright, then the factoring of it is probably the most messed up portion. Looping factors, square roots, bring the sign down, don't forget the quantity squared. Red thing factors, square root of y squared is y, square root of 16 is 4, bring the minus down. What does all that add up to? 144. I love that number, because that's perfect square. So my center is at 5, 4. And my radius is 12. Awesome sauce. Simple day.